In this video, we will discuss about minimum obstacle removal to reach corner. You are given a zero index 2D integer array grid of size m cross n. Each cell has one of two values. 0 represents an empty cell, 1 represents an obstacle that may be removed. You can move up, down, left or right from and to an empty cell. Return the minimum number of obstacles to remove. So you can move from the upper left corner to the lower right corner. So what they are saying is that in the input, we are given a grid in which we have two values. 0 represents an empty cell and 1 represents that there is an obstacle in that cell, right? Now, in one move, we can either move to the top, to the left, to the right or towards the down, right? Now, we need to move from top left cell to the bottom right cell and we need to identify that how many minimum number of obstacles have to be moved while we move from this cell to this cell, right? So if you see in this particular case, when we are at this initial cell, we can either move towards the top, towards the left, towards the right or towards the bottom, right? So here top and left cell is not there, so we can either move to this cell or we can move to this cell, right? Now here both the cells are having obstacle, right? One is present here and one means obstacle. So then that means we will have to remove an obstacle from one of these and then we can proceed further, right? So if we move to this particular cell, then we have removed one obstacle till now. Then from this particular cell, either you can go here, you can go here or you can go here, right? Since this from this 0 we have already come here, so there is no point of visiting it again, right? So we can either move down or towards the right. In any of these, if you will move, you will again have to remove one obstacle, right? So you can again choose any of them. So let us suppose that you choose this one, right? Now in this particular case, again you can move here, here or here. Top we won't go because it is already visited, right? So here these two cells are having an obstacle, but this is not having an obstacle, right? And we need to minimize the number of obstacles that we are removing, right? So we will try to utilize this particular cell. So basically we came from this 0 to this one, from this one to this one, and from this one to this 0 we are going. Until now we have removed two obstacles, right? Then when you will come here, you can go either here or top. So we will choose this one, right? So when you will come here, the path will look like this. And in this particular path, we have removed only two obstacles, and that is the minimum number of obstacles that we can remove in this particular grid, right? So 2 is going to be our answer in this particular case, right? So now how are we going to solve this? So see, we are trying to identify a path that starts from the upper left corner towards the lower right corner, right? And we are trying to minimize our number of obstacles, meaning we are trying to choose such a cell in our path which is not having an obstacle, right? So what we can do is that we can apply breadth first search here, right? Not exactly breadth first search, but we will modify it somehow to incorporate the logic for finding out our answer. So see, what I am saying is that when I am at a particular cell, I know what are its neighboring cells. Neighboring cells meaning top, left, bottom and right, right? Now, out of these cells, I want to prioritize those cells which are empty, right? Because I want to minimize my number of obstacles to be removed. So the cells which are empty, I will try to prioritize them over the cells which are not empty, right? So now, in breadth first search, what we do? We take a queue, we add the current cell into it, then we take it out from the queue, whatever is its neighboring elements that we push on to the queue, right? But here I want to assign some priority to my cells, right? So instead of queue, what I will do is I will take a DQ, right? Now why I am taking a DQ over here? So see, in a DQ, we can push from the front as well and from the end as well, right? And we can pop also from both the sides, right? So see, now, since I want to give priority to the cells which are empty, what I will do is that for each cell which I am considering, whatever is its neighbors, out of all those neighbors, whichever cells are empty, those I will push from the front side. And whichever cells are having an obstacle, that I will push from the back side. Then what will happen is that when you will go to the next iteration, then the cell which was empty, that will be considered first, right? So we have assigned a kind of a priority to ourselves that okay, only consider the empty cells first and then consider the non-empty cells, right? And also we will have to maintain a visited matrix also, so that a cell which is already visited, we don't visit it again, right? So we will also maintain another grid, we can say. Let's name it visited, and we can keep all the values as -1 initially, right? So what are we going to do is, so if we take an example, if let us suppose that our grid looks like this, right? So these are the empty cells and this one is having an obstacle, and the indexes will be 0, 1, 0, 1, right? So what I'm saying is that in the DQ, we will push the current cell. So now, what all things do we need to push in the DQ? So since we are pushing the cell, we need the row and column, definitely, right? But we also need to know that till this particular cell, how many obstacles have I removed, right? Because ultimately my goal is to return the minimum number of obstacles which I have removed, right? So I will have to maintain that as well. So in my DQ, we will push three things. The first will be the number of obstacles that we have removed till this particular cell, then the row of that cell and the column of that cell, right? So initially, since we are standing at this particular cell 0, 0, and here the number of obstacles removed are also 0. So in our DQ, initially what will be present? 0, 0, 0, right? If I write, this is the obstacles, this is the row, and this is the column, right? This is our DQ, right? Now, what will happen is, what do we do in breadth-first search? That while our queue does not becomes empty, we keep on taking the front of the queue, right? So similarly, here also, while our DQ is not empty, we will take the front element, right? So for now, in our DQ, the front element is this, right? So the number of obstacles are 0, row is 0, and column is also 0. And we will remove this from our DQ, right? Now you will consider the neighboring cells of this, right? Now, what are its neighboring cells? 0, 1 and 1, 0, right? Now, one of them is empty and one of them is having an obstacle, right? So, which one will be prioritized? The empty one, right? So, first, this will be pushed from the front of the DQ, right? So, since this is also an empty cell, our number of obstacles are not going to change. Whatever is this obstacles that we have got, we will push it as is for this particular cell also, right? So, now obstacles will be 0, row is 1 and column is 0. So this is pushed from the front of the queue. And then since this neighboring cell is non-empty, it will be pushed from the back of the DQ. And since this is an obstacle, so our obstacles have to be increased by 1 because this needs to be removed if we are considering this cell in our path, right? So for this, in our DQ, we will push 1, which is the number of obstacles, then row, which is 0, and column, that is 1. Right? And now whenever we are taking a cell from our DQ, then we also need to check whether we have reached the end of the grid or not. Meaning if we have reached the bottom right corner or not. So right now we have not reached the bottom right corner. So we can move forward. And since we have visited these two cells also, we will have to mark them in our visited matrix as well. Right? So see, we are also going to maintain a visited matrix. So this we mark it as visited. Initially all the values will be -1. Right? And since firstly, we had pushed the upper left cell in the DQ, right? So initially we will mark that particular cell also, right? So this we can mark as 1. And then here, when we were checking the neighboring cells for this particular cell, first we had to check whether that particular cell is already visited or not. Since 1, 0 and 0, 1 both were not visited, that is why we pushed them in our DQ. And since now we have pushed them, so we will also have to mark them as visited, right? So now this will be removed, and again we will pop an element from our DQ. So this will be popped out. Number of obstacles will be 0, row is 1, column is 0. Right? So this will be removed. Now for this, is it the bottom right cell? No. So let's see its neighboring cells. So this is the current cell that we are considering. The neighbor cell is 0, 0 and 1, 1. But if you see 0, 0 is already visited. So this one we won't consider. So we will consider 1, 1. Now for 1, 1, it is an empty cell. There's no obstacle. Then that means these number of obstacles are going to remain the same. And since it is empty, we will push it in the front of our DQ, right? So what will be pushed? Number of obstacles, which is 0, row, that is 1, column, that is 1. So this will be pushed and it will be marked as visited in our matrix. So this will be 1, right? Now again, we will pop the front element from the DQ. So our obstacles will be 0, row will be 1, column will be 1. Now you will see that the row and column are the bottom right cell of my matrix, right? Basically, the row has become equals to m minus 1 and column has become to n minus 1, where m is the number of rows and n is the number of columns. So then that means for this cell, whatever are the number of obstacles that you have got, that is going to be your answer. That is the minimum number of obstacles which have to be removed. So as soon as my row become equals to m minus 1 and column become equals to n minus 1, we can return the obstacles, right? And why were we able to get the minimum number of obstacles here? Because we were prioritizing all the empty cells before the non-empty cells, right? So let us quickly look at the code to understand it better. So first of all, let us create the 4 directions in which we can traverse. So we will create a vector of vector and it will be an integer. Let's name it directions. First we can keep as 0, 1. So this is towards the right because we are doing plus 1 in the column. Next is 0, minus 1. So this is towards the left, column minus 1. Then for down we will do 1, 0, row plus 1, and for top we will do minus 1, 0, that is row minus 1. So these are the 4 directions. Now let's take the size of our grid. So the number of rows, that is m, will be equals to grid dot size, and the number of columns, that is n, will be equals to grid of 0 dot size. Right now let's create a grid for marking our cells as visited. So we will create a vector of vector integer. Let's name it visited, and then what will be its size? M cross n, right? So m comma vector int n comma, now initially we are marking all the cells as unvisited, so we will keep it as minus 1, right? Now we need to create a DQ, right? So we'll create a DQ and it is going to store 3 values: obstacles, row and column. So we will create an array of type integer. Its size will be 3 and let's name it D. Now in the DQ, we want to push our initial cell, which is 0, 0, right? And for that, the obstacles are also 0. So in our DQ, we will push 0, 0, 0, right? 0 is the number of obstacles, row is 0, column is 0. And we need to mark this cell as visited also. So in visited, at index 0, 0, we will make it as 1, right? Then what we need to do? We need to run a loop that while our DQ is not empty, while our DQ is not empty, take the front element from the DQ, right? So this will give us 3 things. One is the obstacles, right? Next is the row and next is the column, right? So this will be equals to DQ dot front, right? And then we can pop this out. So we are popping it from the front. So D dot pop front, right? Now we need to check that if the row has become equals to m minus 1 and column has become equals to n minus 1, then return obstacles from here itself, right? Because we have reached the target cell, right? Otherwise, we will consider all the neighboring cells of our current cell, right? So we will run a for loop in the directions vector. So for auto direction in directions, what we will do is we will find out the new row and the new column. So new row will be equals to row plus directions of 0 and new column will be equals to column plus direction of 1, right? Now we need to check whether this new row and new column is valid or not. Valid meaning whether it is lying within the range of our matrix or not. So what we will check is that if the new row, so let's name it row, yeah. So if the new row is greater than equals to 0 and new row is less than m, right? And new column is greater than equals to 0 and new column is less than n, right? So this is telling us whether this particular cell is valid or not. And the next condition is going to be that if it is valid, then it should not be visited. We are visiting it for the first time, only then we will consider it, right? So we will put another condition that if visited of new row, comma new column is equals to minus 1, right? Only then we will consider this. So let me just expand this. Yeah. So now since we are considering it, we can mark it as visited. So in our visited vector at new row, comma new column, we will mark it as 1, right? Next, we need to check whether this particular cell is an empty cell or it is a non-empty cell, and accordingly we have to push it in our DQ, right? So we will check that if grid, this is the original grid that is given to us in the question. So if at index new row, so this will also be row, comma new column is equals to 1, then that means this is an obstacle. So in that case, we will push this cell from the back of our DQ, right? So in the DQ, we will push back the number of obstacles plus 1, right? Because here we need to remove this obstacle also. So that is why we are doing obstacles plus 1 and then new row and new column, right? Otherwise, if it was an empty cell, in that case, in our DQ, we will push it from the front. So D dot push front, and then obstacles will remain as is, row will be new row and column will be new column, right? So with this, we will be able to identify the minimum number of obstacles to be removed. And since the path is always going to exist, right, we will always be able to traverse from the upper left corner to the bottom right corner. So our answer will be always returned from here itself. So here we can return a dummy 0, right? So let's quickly run this code. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.